Hello again. Let's continue our tutorial of chapter 2. Okay, let's do question number 5. Okay, let's read the question and try to answer this question. Okay, so a mass M is suspended from a spring with a stiffness 4,000 Newton per meter and is subjected to harmonic force having amplitude of 100 Newton. So just you need to draw an illustration to spring and mass, okay, and the mass is it's not given, but the stiffness is 4,000 Newton per meter and subjected to applied force, which is this one X, and it's gonna be applied force Ft. Okay, so the amplitude of force motion of the mass is observed to be 30 millimeter. Then amplitude will be 30, amplitude is 30, F naught is 100 Newton, and K is 4,000. Find value of M when the frequency of applied force is 3 Hertz. Okay, so let's do the first part. A is F of the applied force, not the natural frequency, will be 3 Hertz. Okay, how can we find that? So now what type of force? Is it damped? Is it damped? We have damper in here. Viscous damper we don't have. So that means this one will be forced undamped oscillation, right? Force undamped oscillation. So how can we solve that? We will apply the formula. You remember previous question? The amplitude is equal to F naught K minus M omega squared. All right, what we need to know is find the value of M, which is the kilograms, the mass. Okay, so the formula, let's write the formula. The formula is amplitude equal to the amplitude of force over stiffness minus M omega squared. Omega we can find it from 2 by F, right? So omega will be 2 by F. Let's derive M from this equation first, because the amplitude is given, right? Which is 30 millimeter. So we multiply in here, we divide it in here, then what we'll get? F naught divided by A, okay, K minus M omega squared. We'll be having something like this, right? So we need to bring M in here. So what you'll get? F naught minus, okay, so let's do that. So we'll have this one, we move K to the other side, isn't it? So we'll have F naught over A minus K, and you divide all of them in here by minus omega squared. Then you'll get the mass, right? So you just put the values, then F naught is given. Yes, A is which is 30 Newton, 100 Newton. Then A will be 30 millimeter, and K will be 4,000 Newton per meter, and omega we can find it by 2 by F. So omega will be equal to 2 by F. Let's call it 1. Okay, let's call this one 1, and this is 1. So 2 multiplied by F, which is 3 Hertz. Then that one be 6 pi radians per second. So let's try find this one, and so M1 will be equal to F naught is 100, and this one 30 multiplied 10 to the power minus 3 minus 4000, all divided by minus 6 pi squared. You should have positive value, okay? You don't have negative mass. Can you calculate that one? Where's your calculator mass? So you have to bring your calculator every class, because your practice will be, if you make mistakes, then you make it at the class and not in the exam. This one also can be, if you apply multiply A by K, when you divide it by K, so you will get, if you apply A, okay, both sides, then what you will get, maybe F naught minus AK divided by minus 1A minus A omega squared. How much? Yes, it's the right answer. 1.876. What? Kilogram. Okay. So M2, okay, which is B. If you go, if you apply the frequency 5 Hertz, you just put omega 5 Hertz, and that one will be omega 2 will be 2 multiplied by multiply 5, and that one will be 10 pi. Okay, then what you'll get 100 divided by 30 multiplied 10 to the power minus 3 minus 4000, okay, divided by minus 10 pi squared. What you will get? Then the mass will be different when you have different frequency and same amplitude of displacement. So, very good. It will be 0.675 kilograms. So we solved this question. Is it difficult? Yeah, it won't come. It won't come. It will come maybe. Yeah. So, but as this easy will be part of the question. Okay, part of the question. Then it won't be repeated by 2 times, two different frequencies, right? So let's move to the question number 6. An object of mass 0.2 kilogram. The mass is given. Okay, the mass is given. Is hung from a spring whose spring constant is 80 Newton per meter, which is the stiffness. The body is subjected to damping force where C is 4 Newton second per meter. So what's the system? It will be a hanged mass, right, supported by a spring, and also there is a damper in here which has constant C, okay, which is this one, 4 Newton second per meter. Set up the differential equation of motion of free oscillation of the system and find the period of such oscillation. We need the equation of motion, right, of this. Is it free or forced oscillation? Is it? Where's force? They didn't mention any force in it. Free oscillation. Okay, it's given. You have to read the question clearly. Okay, so there is no applied force. Only there is free oscillation, means there free damped oscillation. Okay, free damped.
Damping force. Damping force.
Due to the damper in here. So there is no force. There is no driving force. This is free oscillation. Means you don't apply force on the mass. You just displace the mass and let it until the oscillation gonna die out. Okay, which is die out. It's gonna have less amplitude until it becomes zero after a number of cycles. Right. This is what's the meaning of free damped oscillation. Okay. So now we have free oscillation. And we need to find the equation of motion and also the period. The period, if you remember, is noted as T. So, how can we find T? It will be related to the frequency, right? Which is the natural frequency or the damped frequency. So, it's damped, right? So, it's damped, so we need to have it as a damped period, okay, damped period. And damped period become Td equal to what? 2 pi over omega or omega over 2 pi? 2 pi over omega, right? And that's 1 over Fd, okay? So you have to know that, okay? So then we have to make the equation of motion. Can you make the equation of motion? So equation of motion will be having damping, and we have to, so what you will have, summation of all forces equal to mass multiplied by acceleration. So we have acceleration here. It's not equal to 0. So the forces acting over the mass, we have the mass, all right, and we have to apply the forces. So the first force is the spring force. As you pull it in this direction, or if it's moving in this direction, then we have two forces acting over that. Will be the spring force and damping force. Okay, the spring force and the damping force. Okay, we don't have any applied force. So the applied force is going to be equal to 0. Okay, and you have to remember, as this is hanged, then there is no effect of weight over the oscillation. Okay, there is no effect of the weight over the oscillation. So forces will be minus Fs minus Fc equal to mx double dot x. So if you move this one to the other side, and what you'll get, m double dot. So this is what I mentioned in the last semester. You remember? So if there is a weight, right? Okay, in the perpendicular. Okay. So for example, if you think because it's moving in this direction, in the direction of motion, right? So the weight, it doesn't affect, right? So if you have a spring mass system, all right, you have the weight is going to cancel, all right? It's going to cancel the within that will be, the weight is not going to be affected because we have the acceleration, or the mass is going to accelerate, or this form, and mass multiply acceleration is much bigger than the mass. Okay, and the spring force and damping force also is much bigger than the effect of the weight, so it's going to be cancelled. You have to put that one in your mind. Okay, then let's make this formula. We move the other side in here. So Fc will be plus, if it's negative, become positive. Then what we'll have, C multiplied by the damping force will be constant C multiply displacement x, or velocity x. dot, okay? Velocity x dot, because the damper is going to reduce the velocity. And the spring is going to reduce the displacement, right? So this is what, this is what's the meaning of the damper, the difference between the damper and the spring stiffness. So we have x and that one equal to 0. Then this is the equation of motion. If you write it correctly, then you will get the mark, okay? You will get the mark. But this is very general formula, equation of motion, okay? So if it's forced, then this the right hand side in here won't be 0, okay? Then you have to put the force, which is related to the amplitude of force, and also the direction, which is cosine omega t plus the phase shift angle, if you remember from the previous classes. All right? So the first part is given. What about the second part? How can you find it? How you can find TD? We need TD, right? The damped period. Okay, the damped period. Before we find the damped period, okay, we already have C, which is 4 Newton second per meter. And we can find omega naught. What's omega naught? Square root of K over M. Do we have the mass? Is it given? 0.2. And K is 80. So it will be nothing but 80 divided by 0.2 under square root. How much you will get? 20 what? Marsam? Mama, you don't remember? Radians per second, yes. Radians per second, okay? So now we have omega naught. We just apply the formula what we remember before. Omega d squared will be equal to omega naught squared minus gamma squared over 4. Gamma is what? Gamma will be C over M. How much is gamma? 4 over 0.2, and that one will be how much? Why 2? You don't divide by 2 in here to get 2. So we'll have 8, right? كم طلع؟
No, 20.
20? 4 divided by 2?
0.2. 4 divided by 2.
How much? 20? Okay. So it'll be 20 what? Newton second per meter, and this one kilogram will be second, 1 over second, okay? That will be 1 over second. Will be second to power minus 1, okay? So this is the unit of gamma. So the gamma, we already find it. Omega naught, we find it. Omega d, we can determine it, right? So omega d, if we have the square root of both sides, then will be omega naught squared minus gamma naught over 4, gamma squared over 4, then the square root. Let's substitute all what we have in here under the square root, okay? Omega naught will be 20 squared minus gamma squared will be 20 squared divided by 4. Can you give me the answer of that? No. You forgot to put 20 squared. We have 17.32. 17.32. 3205. What's the unit, Martha? What's the unit in here? Radians per second, okay? So now we found omega d. Can we find TD now? Which is the period. The period of the damped oscillation will be 2 pi over omega d, and that will be 2 pi over 17.32, what you will get.
0.36
Yes, 0.36 second means, so the period, okay, it's time. So for one cycle, how much time it's going to take? It will take 0.36 second. Clear? Clear? Let's continue. What's the next question in this, the second part? The object of this is subject to sinusoidal force. Now, the previous, the A part A will be free damped oscillation. Now we are going to apply force. Okay? It will be subjected to sinusoidal force given Ft equal to F naught sine omega t, where F naught, which is the amplitude of the force, or driving force, will be 2 Newton, and omega, which is not the natural frequency, but the frequency of driving force, which is 30 radians per second. In steady state, what is the amplitude of the force oscillation? Now, we use the formula, right? We use this formula for only free damped oscillation. But now we need another formula for forced damped oscillation. What you are going to use? Okay, so the previous class, we discussed about this formula, which is related to the frequency ratio and the damping ratio. So we have to put that one, to use that one to find the amplitude, okay? To find the amplitude of oscillation in here. So what is the amplitude of the oscillation at steady state? So that formula, it will give you the, or P. So if you go, the formula will be for the damped oscillation, damped force oscillation, right? Which is it's gonna be 2.35, okay? 2.35 formula number or equation number 2.35, page number 30. Okay, so if you use that formula, A is equal to F naught over K divided by square root omega naught squared minus omega squared all squared plus omega gamma squared. All right? So now we have this formula. Do we know of F naught? Is it given? Okay, it's given, which is how much? It's gonna be 2 Newton. And omega naught, we determined it already. Okay, and omega is given, which is 30 radians per second. Omega is here given, and the damping, which is gamma, C over M, also we determined it before, which is 20. You just put that one, then everything will, let's put the input to the point, which F naught is going to be 2 Newton. The mass is 0.2 kilograms, and omega naught, we have determined it 20 radians per second, and omega is given, which is 30 radians per second, and the gamma we have calculated in the previous part, which is 20 what? Second to power minus. So you just plug all these inputs in the equation. What you will get, A will be F naught 2 divided K is 4,000, isn't it? Sorry. Be M, not K. It is M. And this one, you've seen it in the previous course also. We used it before. 2 over M is how much? Is 0.2. And multiply by 1 over square root omega naught is 20 squared minus 30 squared, all squared. Luckily, we will have a positive number in here. Plus omega is 30 and gamma is 20, all squared. Try to calculate and let me know how much the amplitude. And this is steady state, means what? At the beginning, it will be a transition, changing from, then become steady state. There is no change by time. Okay? 610, no.
No, 700.
0.0128, right? 0.028. Okay. So, what's the unit, Hamoud? Okay, this is meter. And that's all about this way. But there is another way to solve this one. Maybe you forgot about it, okay? We will put the damping frequency, then we can find the solution for the part A and B. So there is alternative solution for that, okay? So let me copy the question, then we'll do it in another way. So both of them are correct if you'd like to solve it, okay? If you'd like to solve it, then become both way are correct, but don't mix the formulas, okay? So what you will get in here? So for part A, what you need to know in part A compared to the previous one, the same equation of motion, there is no change, but what you need zeta. You remember zeta would be the C over critical damping CC. CC is what? 2 square root mk, right? M multiplied by K. We have M 0.2, isn't it? Which is this one. And K, which is 80, right? Then we find CC, right? Can you calculate that? How much you will get? Huh? So we depend on Hamoud now. In the exam, you cannot depend on him. So you will get 0.5. Huh? No. It will be 4. 0.2 multiply 80. And all under square root. Now? It will be 8. Are you sure 8? Will be Newton, second, per meter. Then you just find zeta. Zeta, we already have C in his will be 4 divided by 8 It will give you 0.5. What's the unit? Unitless, right? Which is friction, a fraction, okay, which is 0.5. Great. So we find zeta. Omega d would be equal to omega naught square root 1 minus zeta squared. This is formula you remember? So it will be from the dynamics course. Omega naught, we determined it before. Omega naught, how much? We did it before, right? 2 pi f. Or omega naught with square root of k over m will be 20. So it will be omega t will be 20 multiply 1 minus 0.5 squared. And that will be omega d. So omega d will be around 17. Similar what you have got in the previous method. Radians per second. So Td would be 2 pi over omega d. And that one will be 2 pi over 17.32. And it will give you around same 0.36 second. Okay, this is part A. Part B, also there is another formula for that, which is equal to the amplitude with part B. The amplitude is equal to F naught over K divided by square root of 1 minus R squared. It's R, not omega. Plus 2 zeta R all squared. Zeta is what? Is damping ratio, but R is the frequency ratio. So frequency ratio R will be omega over omega naught. Okay. And that one will be what? Will how much omega? Given 30, right? This is 30, and this one you calculated as 20. Okay. So you'll have 1.5. So you just plug in zeta and R, and you know K, and you know F naught. How much F naught is given? In the question, right? 2 Newton, right? You just plug on all the numbers in here. F naught is 2, K is 80, divided by the square root of 1 minus 1.5 squared plus, this is squared, okay? And 1.5 should be squared as well. 1.5 plus, 1.5 squared, all squared. Then what we'll have 2 multiply zeta is how much? We have determined it 0.5. So multiply by 0.5 multiply by R, which is 1.5 all squared. Calculate that one and let me know how much you are going to get. And it should give you the same answer of the previous method, okay? Which is 0.0128, which is 0.0128 meter. If you divide it by 1,000, become 12.8 millimeters. Did you find that? Yeah. So this is another way how to solve this question. Now you know damped or free undamped free oscillation, or damped free oscillation and damped forced oscillation. We have different methods how to calculate the amplitude. All right, that's all about today's class. I'll give you the next in the next class. We'll give you the tutorial, the rest of the tutorial. Thank you for coming.